So the only thing we had left to do on example 11 yesterday was to find the decimal value of k by solving that equation. I'm not going to go ahead and do that because I'm not going to ask you one like this on the test. But there is one like this, I think, on the homework. So you could graph this in y1, just like we did on the quiz. Graph the left side in y1, graph that in y2, solve for k. You got 3 decimals, and then all you do at the end is you plug that value of k. Let's say you get k equals, let's say you get k equals, let's just say you get 3.14. Okay, you won't, that's pi, right? Then you would just plug that back in right up here, and you'd say, so f of x equals 500 all over 1 plus 24e to the negative 3.14. That's whatever your k is to 3. Let's do 3 decimals, 3.141, because we like 3 decimals. 3.141 times x, and you're done. That's how you write the equation. All right? So I'm not going to find the exact value of k, but you get the idea. All right, so that's the end of 11. Now, example 12, we did this on the previous section in 4.1. It's how we closed out the section. Remember the rumor about Carlos, Petunia, and Wallace, and the titanium necklaces were a sham. They didn't work. This is the exact same thing, except it's also ripped from the headlines. It's swine flu. Now, I put an asterisk by it here because whenever we test, and we're testing Monday, your free response question is going to be very similar to this. And it's not a difficult question. So hopefully everybody will make 100 on the question on the test on Monday. Your free response will be like example 12, yes. Yeah, and which is like what we did on the last example in the previous section. So it's not even the first time we're seeing a question like this. And it's not that difficult even. We're doing it mainly on the calculator, and I'm giving you the equation. So really what students get docked on is the notation. Okay, so you need to make sure you're focusing on the notation. So 2020 kind of takes the cake for shutdowns when it comes to school, right? That was from spring break on to the end of the year. But in 2009, well before 2020 happened, we actually had to close our doors on campus again because swine flu was kind of taken over. And it happened in May, right around the time AP exams took place. So it was kind of a challenge. I had to give the AP English exam here. We had to take people's temperature at the door, and they came in here in a small group. And we gave the AP exams in small groups, small batches. But it was a real thing. Swine 09, that's easy to remember. Swine 09 is what happened. And we had 22 students on campus roughly. The freshmen were still up here at that time. So here's a logistic equation that kind of modeled the spread of swine flu. S of t equals 2,200. That's our limited growth. That's the student population. Over 1 plus 999 e to the negative 0.1 t. Okay, so that's your logistic equation. S is the number of students that have been infected after t days. So we have units of students and days. T equals 0 is the day the first flu begins to spread. So step 1, we go to our calculator, we get it in there, right? And pretend you're taking the test. You go to your calculator. Alpha x, remember, is your quick way to get your horizontal division bar. 2,200 divided by 1 plus 999e, which is second ln, to the negative 0.1x. Now, before you do anything else, double check, triple check, make sure that you have it typed into your calculator correctly. Because if you have it typed in incorrectly, you're using the wrong equation, you're going to answer all of it wrong. And I'm not going to be very sympathetic if you can't even get it into your calculator correctly. Okay? Yeah. How do you get the horizontal division bar? Alpha x. You see the little green box over the green box? You activate that alpha x. Alpha x. It's right next door. Y'all see that? Alpha x?
Right next to alpha.
X is right next to alpha. It's x t theta n. Alpha x. You can also go alpha y equals number 1. That does it too. Alpha y equals number 1. But there's a shortcut on this calculator. Alpha x. Okay. So I got it in there correctly. Now we go to the window. We're measuring time on the x-axis. Someone put 0 as my lower bound. How many days do you want to give for the flu to spread? This is where you just kind of Yes, and then change it if you need to. 4 days? 40 days. Okay, let's do 40 days. I heard 22, but we'll go out to 40. So not quite 6 weeks, right? X scale, we'll leave it as 1. We're measuring students on the y-axis, so we'll put 0 there. And now I'll put something that is bigger than 2,200, like 2,500. We know not 25,000, 2,500. And then I hit graph, and I should see an S curve. Do you see the S curve? I can see it slowly increasing. I need to go out further, so I need to go back to my window and change 40 to something bigger, like what? 200. There you go. Let's get serious. Now do you see the S curve? Now I see the S curve. Okay, so I know that I have it graphed correctly now, and I have a nice window. So I see the nice S curve. All right, so now we can answer the questions, and now it's all about the notation, remember, to get credit, full credit. How many students were originally infected? So on part A, we're going to write S of 0. S of 0. And then from the graphing screen, if we want, we can hit trace, and Ryan asked us during the quiz, if you hit the trace button, it's going to give you a point automatically, but you could type right over that. Just hit trace and then type in 0, hit enter, and we get 2.2. 2.2, and it doesn't say to round to the nearest student, does it? So we're just going to leave it as 3 decimals unless it terminates prior, like this one. It's 2.2, and then we're going to put units of students. Now there's another part here at the end of day 3. So now we'll do S of 3, and we could just hit 3 enter, or trace 3 enter, and we get equals 2.968 or 2.969. I'm going to truncate always, students. And then at the end of day 10, so S of 10, we'll just type in a 10, trace number 10, and we get 5.969 or 970 if you round. I'm truncating every time. I don't even want to bother rounding, having to add 1 if I need to. I'm just going to chop it off, which is fine. And it doesn't say again to round to the nearest student, so we're just going to report 3 decimals. We can interpret that as we may. All right, so that's it. So that would get 3 checks right there. And if you're missing any of the pieces like S of 0 or the students, you're going to lose the check. If you just have a number showing there, you're not going to get credit. That's easy, right? That's easy, okay? If you want, remember, you can also go to the home screen, quit, second mode, and you can go alpha trace number 1, and you can also type in a 0 there like that and get the answer that way, okay, if you want to do that. All right, part B. After how many days have 10 students been infected? Now, let's practice our notation. 10 students is not a t value, is it? It's an s value. So here's what I'm going to be looking for. I'm going to be looking for s of t equals 10. That's going to get a check. That's the equation you're solving. S of t equals 10. You could write the whole thing S of t if you want, 2,200 over 1 plus 999, but that's a lot of writing. It's a calculated question. It's called S of t, so just say S of t equals 10. And then I go to Y2, and I graph 10, and I look to see where it intersects. Now, it's way down there at the bottom, but it'll find it. So second trace number what? 5. Second trace number 5. Enter, enter, enter. Underneath there, I put t equals 15.176, and that's days. So a little more than 2 weeks. So this was kind of a slow-spreading swine flu, which is about right. It kind of spread slowly. I think we only had like 3 reports of swine flu on campus, but it was very, very contagious, and we shut down kind of prematurely in hopes of curtailing it, which it worked. 15.176 days. Okay, so everyone okay with what to write? S of t equals the number, and then underneath there, t equals the x value. All right. C, after how many days is the flu spreading at the fastest rate? This requires you to remember something about the equation itself. It's the inflection point. The inflection point is where this graph is the steepest. That's where it is spreading at the fastest rate. So you're going to have to show me that you're setting S of t equal to what? No, whatever your carrying capacity is divided by 2. Yeah, it's the halfway point. Vertically. It's the vertical halfway point. So you can say 2,200 divided by 2. I would take that. Or if you know what half of 2,200 is, you can say it's 1,100. Either one of those. That's going to get a check for setting the equation equal. Now I go back to Y2, and I change 10 to 1,100, and I graph, and you can see that it crosses right through the middle. And that's a good visual verification that that is in fact the inflection value. And then we do the same thing. Second trace number 5, enter, enter, enter. And underneath there we get t equals 69.067 days. So you're going to get one check for the equation that you're solving and one check for the answer. If you do it any other way than this, if your notation is anything different than this, you're going to risk losing the check even though you have the right numeric answer. It's about presenting your work, communicating how you're getting your results. All right, so when is the flu growing at the fastest rate? When the vertical is at the halfway point, okay, which is half your L. You got to remember that. That's the inflection point. Okay, part D. According to the model, after how many days will the entire student body come infected? According to the model, how can you tell?
By the L.
So when, according to the model, after how many days will the entire student population become infected?
2200.
No. After how many days? That's an input. That's an X value. Will it ever reach 2200?
No. SFT equals.
It looks like this, right? Here's 1100. And we got 2200 up here. And what's happening? What's up at 2200? An HA. Is it actually going to cross or reach the HA? No, that's what the model says. So according to the model, will it actually ever reach 2200? No. So the answer to this question on part D is never. According to the model, never. Since the graph has an HA at y equals 2200. According to the model, you'll get that last student who's partially infected, but he's never fully infected. He's just closer and closer to becoming fully infected. How can you tell? It's the horizontal asymptote at y equals 2200. Now, in actuality, if we didn't take any measures, would the entire student population get infected? Yeah, more than likely so, right? So every model has its drawbacks, right? It's just used to predict trends. All right, so here we go, part E. If the school has a policy to shut down, if at least 5% of the student population is infected, after how many days will we shut down? All right, 5%. We need to figure out what 5% of the student population is, don't we? What's 5% of 2200? Well, we can go to the home screen and type 2200 times what number? 0.05, or times 5 divided by 100. Yeah, that's 5%. That equals 110 students. We shut down well in advance of 110. Okay. So now I'm going to give you a check for setting it up. What are we going to do? S of t equals what? 110. There's a check for that. This is the third time now we've done a problem like this in this problem itself, where I'm giving you the y value. Now we go to y equals and we change 1100 to 110. And it's down there, and then we put t equals, second trace number 5, enter, 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 and we get 39.623 days. So over a month went by, and it was getting bad, and like, okay, this is bad. Out of 2,200 people, we have 110 sick kids. We're going to shut this down before this becomes really an epidemic. Okay, and it wasn't a pandemic. It was an epidemic. It wasn't like nationwide or globally. It was just kind of a regional thing. How is that for a free response question? Everybody should be getting all of the checks on that, shouldn't they? Everybody should be getting all of the checks on that. The only way you're going to lose checks is if you deviate from the notation that I just gave you. Okay, or if you typed in the wrong equation, right? Which is why before we even start, we not only double check, we triple check. It's a quadruple check, quintuple check. Straight from the quiz, we'll quintuple check. Make sure it's in there correctly. Okay. All right, that's it. That concludes the notes. Your homework, your worksheet is due tomorrow, which is Friday at 9 a.m. like usual. And then tomorrow in class, we're going to work an old test. An oldie but a goodie. And it'll get you ready for Monday's exam. Yeah, I'll put it in Canvas. Yeah. Monday is the test over 4.1 and 4.2. It's just over those two sections. Okay. All right, that's it. Any questions? We're done with 13 minutes to spare. You have the rest of the time to work on your homework. Yeah.